All right, so today we're going to do the acids and bases calculations table, and the difference between this one and the one from yesterday is the fact that now you kind of have to decide which formula to use based on the information that's given to you, whereas yesterday it was given to you at the very beginning of every section, so you knew exactly what to do. If you look at the very first one, you're going to find out that it gives you the pH, and it tells you that it's a pH of 3.78. Right then and there, it tells you whether it's an acid, base, or neutral, so you can automatically fill that in. So we know that 3.78 is below 7, so it's an acid. Okay, for the rest of them, I'm going to ask you to please show the work and put it on a separate sheet of paper and staple it to that worksheet right there. Okay, so to find the hydrogen ion concentration, there's two formulas. There's this one and there's this one. So I really can't choose this one because I would need the hydroxide ion concentration, which is one of my blanks. I don't have that. I can use this one because I need the pH, which I have. So that's the one I'm going to choose to use. All right, so I'm going to go ahead and indicate that this is a formula I'm using, and I'm going to substitute the pH with that number that was given to me in the problem. Okay, so here we go. It's 10 to the power of negative 3.7. So as we're putting it into the calculator, it's going to be 10, just like that. The little caret key right there, negative 3.78. So 3.78. Okay, that's what it looks like. The cursor's up here. We want to go ahead and bring it down and press enter. Okay, that's our answer, but we don't want to show our answer in standard notation. Anytime you're calculating your hydrogen ion concentration or your hydroxide, I need those numbers in scientific notation. So I went ahead and put that there as a reminder, which you can do that as well on your paper. If it's a pH or POH, then you're going to put it in standard form, numbers that are not in scientific notation. So in this situation, we're going to do it by hand to place it in scientific notation. Okay, so our number is 0.000166, and what we do is we take our decimal point and we're going to shift it to the right as many times as we need to in order to have just one non-zero number in front of that decimal point. If I would have gone further, that would have been two numbers, making it 16.6, and that would be incorrect. So we stop here. I counted that there was four shifts, so therefore I would write it as 1.66 times 10 to the negative fourth power. Anytime you shift it to the right, it's a negative exponent, and when you shift it to the left, it would be a positive exponent. Don't forget to go ahead and also put your unit, which is going to be the unit for both hydrogen ion concentration and hydroxide. All right, so now to find the POH, we see that the only formula that has POH in it is this one, and that's exactly the one we're going to use, where we're just doing a simple subtraction. Okay, so we're substituting the pH with the pH number that was given to us. Here's a formula that I got from the top. So it's pH plus POH is 14, so 3.78 plus POH is 14. If you're looking at it as in you don't know what to do, just pretty much think of it this way. It should read 3.78 plus x equals 14, so you would be solving for x. So in this case, you would just do a simple POH is equal to 14 minus 3.78, and then you calculate your answer. Okay, my answer is 10.22. There is no unit, so it's just flat out 10.22. All right, and you go ahead and put it into the little space. All right, for the next one, we're looking for the hydroxide ion concentration, and the way we're going to do this is, again, we're going to look at our formulas provided, and the only one that we can really use to solve this is this formula. So we need the hydrogen ion concentration, and we already have it because we went ahead and solved for it earlier, and we said it was 1.66 times 10 to the negative 4. So we're going to go ahead and put it into the formula. All right, this is what it looks like. You're setting it up this way. Now the only thing we're going to do is go ahead and put it into the calculator. And yesterday, I didn't do a very good job of telling you how to put it in there because I'm not very familiar with these calculators, but I found a better way. So I'm going to go ahead and share that with you. Okay, so as I'm putting this one, rather than what I told you yesterday, which was to put in 1 times 10 caret negative 14, we're going to use a different button. We're going to do 1, and then instead of using times 10, we're going to press the 10 to the x. Just like that. And then negative 14. So negative 14 looks like that. We're going to bring the cursor down. Okay, now divide it by. There it is. And we still have to use parentheses. So parentheses. There it is. And then 1.66. 10 to the x. And then negative 4. This is what it looks like. We have to move the cursor and make sure that it's outside. Okay, and then we're going to press enter. All right, so here's our answer, 6.02 times 10 to the negative 11 power. All right, you're going to go ahead and write it down with the unit after it. And because we said that these numbers have to be in scientific notation, we didn't have to worry about shifting a decimal. It came out exactly how we needed it to come out. But keep in mind that I know some of you tend to put the answer exactly how you see it. That's not what you want to do. You want to make sure that you replace that E with the times 10. So you should not write it exactly how you see it, but rather 6.02. I rounded. You can too. And just put times 10 to the negative 11. Here's my negative 11, and then I added the unit. And make sure you do that for all of the ones that are in this column. Okay, as you move on to the other problems, you know, they're going to be giving you other numbers that are in the chart that you're going to use other options. So now, rather than giving us a pH, they give us the hydrogen ion concentration. We have to figure out where to go from there. So I have to think, can I find the pH knowing my hydrogen ion concentration? And if I look at my formulas, yes I can, because there's a formula that reads pH is equal to the negative log of the hydrogen ion concentration, which is exactly the one I'm going to use to figure this one out first. Okay, so entering it into the calculator, we're going to go ahead and do a negative log. So I messed up yesterday as well, I know that too. So it's going to be negative, and I know that I can just press Control, then log, and not at the same time. I figured that out, thank you. And so then shift over here to my right and enter the number 3.89 times 10 to the negative 4. So 3.89. And then remember, we're going to do 10 to the x. Just like that. Negative 4. And then take it outside the parentheses and enter. And we find out that our pH is 3.41005. I would round instead of writing all those numbers. Alright guys, so got my pH. I'm going to leave you with this, as I've already explained from the first example how you would go about finding the remainder of it, especially having the pH already. You know that this is going to be acid because it's below 7, and the rest is up to you. Okay, make sure that you show your work just like I've been showing it on a separate sheet of paper and staple it to your worksheet.